pH fakie. What does pH measure? Well, the acidity of a solution or the basicness. It's how acid or base this is. That's the idea. H3O plus is the thing that we really talk about, but it very, very, very often gets cheated to H plus to the point where sometimes I forget to say that at all too, because you get the same mathematical answers and so forth. So, and it's just slightly harder to write and so forth. So you write it so much that I've seen college professors cheat this to H plus. Everybody just knows that it's really that. What's the English name of H3O plus? Hydronium. Now, if hydronium is getting more concentrated, if the concentration goes up, it's getting more acid, but that makes the pH go down. And that is against what most people kind of think, and it's certainly against what I expected. And I thought, well, this system's dumb. Well, there's a big mathematical reason, and I think I explained it in another tutorial. But if the system is getting more acid, the pH goes down because we used the negative sign. Remember the negative signs we used? And that makes the directions flip. So conversely, if the hydronium ion concentration goes down, then the pH goes up. What's the English name of OH minus? Hydroxide, that says. And this one goes kind of like you think. And this one runs the opposite. If hydroxide, which is sort of the opposite of H3O plus or H plus, if it goes up, the pH goes up. If it goes down, the pH goes down. And a higher pH is called being more basic of a solution, and a lower pH is called being a more acidic solution. Oh, I see. I forgot to do this one. Let's do this. So log of 82 would be 10 to the what power will get me 82. And we would type in log 82. And the answer is 1.91. So that's the exponent on 10 that you have to use to get 82. So log 82 would be 1.91. And again, and this is going to come up later, pH then is really the exponent on 10. So what's the pH for this solution? Well, we're only going to use strong acids in this class, and we'll assume that all the H pluses come off. So if you have 5 of these, you'll get 5 H pluses. If you had 20 of these, you get 20 H pluses. And that means we can just borrow this molarity that we said for the H plus molarity. And so pH equals negative log of the H plus molarity, in brackets means molarity, and molarity is moles per liter. So I'm going to borrow this molarity as the moles of H plus, the molarity of H plus. And to take pH, I'm going to take the negative log of that value. Put it in your calculator and see if you can get it to actually generate that number, that value. And if you can't, ask me and I can try to help you. Also, we know pH plus POH equals 14. So if this one's 1, that one's 13. If this one's 10, that one's 4. So we can do 14 minus the one you know to get the other one. So I'm going to do 14 minus that answer to get me the other one. If I know pH, then 14 minus that value will get me the other one. It will get me POH. What's the pH for this? Now, we do the same thing. We can borrow this, that molarity, as the OH minus molarity. And when I take negative log of that, here's the only trick. I get POH. If you're going to take negative log of the OH molarity, you get POH. And then 14 minus that one will get you the other one. Now for 14 and 15, we have to remember that pH is the exponent on 10, except remember we changed the sign. Remember we said negative of. So if we want to go from pH back to molarity, What we're going to do is tell the calculator, I'm not asking you for the exponent on 10. I'm telling you the exponent. Except remember, we had to change the sign before it goes back in. So we're going to do 10 to the negative 5.2. And that will give us the molarity of the H plus or H3O plus. This is the same thing. Remember, we were kind of cheating. It doesn't matter though. Everybody does it. Try it on your calculator and see if you can get it to actually generate this value. So on 15, if the pH is 4, what's the OH minus? Now, this is going to require a couple logic steps. What I need to find then is the POH. And I'm going to say, well, I know these add to 14, huh? So if pH is 4, POH is 14 minus 4, huh? It's going to be 10. And then pH and POH are the exponents on 10, except the sign is wrong. So if we want to run backward from POH to OH minus, we're going to tell the calculator the exponent. We're not going to ask for the exponent. We're going to tell the calculator the exponent, except we're going to change the sign first, and that will generate the molarity of the OH minus. Notice here I said see the box for directions for 17 and 18. They will apply here except for the last one. So what's the pH of this many grams of HCl? Well, what's pH? It's the negative log of the H plus molarity. So I need that. What is molarity? It's moles per liter. So I need moles. And if you look down there, they already told me liters. So my whole and my information is moles. I need moles of H plus. So I can get it over liters and make molarity of H plus. So I'm going to take the grams, find the molar mass, convert that to moles, and that's moles of H plus. Now, I know some of you will be saying, but no, that's moles of HCl. You're right. Technically, it is moles of HCl, and you have to use the molar mass of this because this is what you added to the water, the whole thing, the H and the Cl together, and that's the molar mass here. But as I was saying before, if you had 40 of these, you'd have 40 H pluses that split off in water and 40 Cl minuses that split off in water. Now, I don't really care about the Cl minus for the purposes of this, so we're going to kind of forget that. But the moles that you get for this, I can borrow as moles of H plus. And I really did that because I need molarity, and molarity is moles over the liters. Divide, and I get molarity of H plus. And then pH is negative log of the molarity of H plus. Remember, I put some directions here. So follow that. We're going to convert the grams to moles. And I know that's really moles of this. You got to use the molar mass of the HI. But all the H's come off, so that moles can be the moles of the H plus also. I did that because I wanted molarity, moles over liters. And I did that because I know I need to take negative log of H plus molarity to get pH. And I also know that 14 minus the one I have, the pH, will give me the one I don't have, the POH. This is pretty much a repeat just for other practice. I'm going to take the grams of the chemical, and that's the molar mass, and convert them to moles. Why did I do that? Because I need molarity. Why do I need molarity? Because I need to take negative log of the molarity to get pH. So this divided by that is the moles of the whole thing, but I'm going to borrow that number as moles of H plus because all the H's come off. Moles over liters is molarity of H plus then. And pH is the negative log of that number. And there you go. And POH will be 14 minus the one you just found. 19 is very similar, except we're going to use NaOH. So when we take the negative log of the molarity, we get POH because we found molarity of OH minus. Let's back up. Let's take grams of the chemical, find the molar mass, and convert to moles. Now this all comes apart. It's a strong base. And I need to make a note of that on the paper. But this is a strong base, and all of them come apart. So if you had 20 of these, you'd get 20 NAs, which I don't care about for this problem, and 20 OH minuses, which I do. So my point is, if you can find the moles of this, it's also the moles of the OH minus. So I'm going to find the moles of that, but I'm going to borrow that number as moles of OH minus. I know that I want pH and POH, and that's always negative log of the molarity. So I need molarity, and molarity is moles over liters. So that's the molarity of the OH minus. Negative log of that number will get me the P number, except remember, you will be getting POH. And that is a classic mistake, and we've all made it to write down pH for this, but it's not. It's POH because I was using the OH molarity. And once I have this, 14 minus the one I have will give me the other one.